right, so this is how to build nightly when there is no night. I am Josh Nixdorf. Hopefully you are in the right place. If not, this is your chance to escape. I won't be upset. I'm a technical director. I am not going to explain what that is. It would take the whole time. I'm with Electronic Arts. You probably heard of us, but if not, here's a little video to remind you. All right, woo, go marketing. I assure you that was the most interesting portion of the presentation. And that's mostly because what we're going to talk about next is builds. I apologize for that, but it's what I know, so it's what we're going to get into. We should start. I'm not here to sell you anything. I do not have the solutions to your problem. I'm barely going to answer the question that I posed in the title. My goal really is to show you guys some of the interesting things about games development that at least apply to our company, with the hope that some of our crazy will make you feel a little bit better about some of your crazy. Really, I want to talk about how my team has come basically into DevOps by accident, how we basically ended up on Jenkins by accident, how I'm terrified about the future, how we're going to stop us from leaving DevOps or Jenkins again by accident. Really, I'm going to get into the dirty laundry. So hopefully you've seen a bunch of presentations where people have been rah solutions and good stuff. Yeah, that's not this one. I'm going to have one slide later to show you that I'm not completely insane, but otherwise we're only going to talk about what we've been doing wrong and what we keep doing wrong. And again, that goal for you guys is to be able to show you when you get past some of the basic problems, the stuff you guys all know how to solve, the stuff that you're meeting and you're getting ideas from other people, the things beyond that, the big patterns of fundamental mistake, those are the ones that keep me up at night, and after this, probably you too. All right, so before we get too into it, I want to give you a little bit of background. I'm going to act like I own the whole games industry here. I think I see someone from Riot over there, so he's going to make all sorts of faces that that's not how it works for us. And he'll probably be right, but he'll probably nod his head a whole bunch too. We're completely insane. Fundamentally, the reason for that is while we talk like we do software, and we might look like we do software, and we'll act like we do software, we're totally part of the entertainment industry. And as I'm going to get into, that means that we have a whole bunch of things that we optimize for that are completely different, unintuitive, and batshit crazy, for lack of a better term. So some examples of this. We all know the joke. We've seen the little graphics where you've got the bug dressed up in a suit and you call it a feature. that really is something that's viable in the video game industry. Not only do we potentially do that all the time, but people do it for us, and it adds longevity to titles. It adds new experience. It opens up gameplay that we never thought was actually going to be possible. I mean, look at the things, if you've ever seen the Grand Theft Auto videos. Some of that stuff wasn't what that game was designed to do. People went nuts, and now they've changed the design to better facilitate that stuff. I mean, even smaller examples would be Tiger Woods 08. There was a bug where Tiger Woods could walk on water. Anybody remember that? Probably not, because people get over it, and it didn't really impact the fun of the game. In fact, all it really did was give us a really great marketing angle the following year where the commercials had Tiger Woods himself reference the bug and then tell you that it wasn't a bug. He really could do that, and proceeded to remove his shoes, walk on water, and make the shot. You know, exactly, right? Like, it gives us huge opportunities. Beyond that, I have Super Mario World up there. Any of you guys who watch Games Done Quick videos are probably aware where I'm going with this. That game is 25 years old now. It's an awesome game. Hopefully you're all still playing it like I am. But what's important about this is there are now people who can beat this game in 48 seconds. Anyone who knows the game knows there's no way that could possibly be at half an hour tops. That's my best time. 48 seconds, because someone has taken the time to figure out all the glitches required to make the game do impossible things. I can't imagine they did this without actually disassembling the code, finding this bug, figuring out how to implement that code in-game, and then doing that. And they make videos, and they win prizes, and there's great competitions. The point is, this game is 25 years old. It is still getting played. People are still exploiting the bugs, and they're having fun doing it. Just that alone makes how we think about quality very different. Segueing into that, our QA department, this will sound blasphemous, and if anyone's here, they'll be annoyed that I said it. Really, when they're doing their job, they're not actually looking for bugs. In fact, that's the worst thing I can have them doing. I have an army of test automation machines that should have found the bugs before we ever got that to QA. QA's job in our industry is about fun and authenticity. They're going to find things that aren't quite right, and then they're going to make a call on what's the likelihood that you're going to experience that. If you do, are you actually going to care about this? And perhaps identify those things that become features for later. But the key is, if it isn't fun, and it doesn't hurt authenticity, and it doesn't make us look like a bunch of yahoos, it's probably perfectly reasonable to ship. And what we identify as bugs in our games, we ship a phenomenal amount of them. Most people never notice them because they're either too rare or, again, they have no impact on those previous things. Anyone who's really into Star Trek might recognize this as the Klingon emblem. The reason I have this is I've made the analogy of game developers being a lot like Klingons. Proud people, usually pretty skilled, always seeking glory. I cannot even begin to get into how important this is to the mindset that it enables at the company. What I would go to for this is these guys are constantly seeking glory. Everywhere they go, everything they do, they want to be able to show their friends, this is the thing that I did. It's not a piece of software that I wrote that you use as a tool that makes your life better. It's this thing that made you have an experience. You may love or hate that, but you have now had this thing. And they can't imagine not being involved in something that doesn't lead to that type of glory. And I mean, I don't want to stray too far into things the legal department might not be happy about, but ultimately, that passion that derives from that allows them to make judgment calls that the rest of you would probably find pretty illogical. They will happily work extra hours without being asked to do it because they can't imagine not doing it. They don't want to go home until this game is the best thing possible. And unfortunately, when things go poorly, that can potentially get exploited. But more often than not, those people are there doing that because they can't imagine doing anything else. I know tons of game developers that have had genuine offers for more money at other industries, at other businesses in other industries, that they turned down because they just could not imagine themselves not working in games. When the market went bad a few years ago, we'll talk about that later, and there were layoffs aplenty, so many of those people have returned back to the games industry simply because they just can't imagine doing anything else. It's important. A thing that might be easy to neglect in some of the crazy that we do is our business model isn't like the software business model. It's far more like Hollywood. We will invest a phenomenal amount of money in development costs and marketing and may have a complete flop on our hands. Maybe you hit it big and you make something that makes a lot of money, but you don't know quite often. For the iterative sports titles, you have a history. Frankly, for any of the iterative titles, you have a history, and that's important. The very first time we do something, it's very hard to make a case case for investment in tooling, in the good development practices. We have no idea if we're going to be building off of this code base or not. And so investment is a serious challenge. Sure, by the time you get to the third one, it's easier to go, hey, we've made a bunch of money off this, maybe now it's time to invest. But by the time you're off to the third one, that first cycle was probably 3 years. That's pretty average in the games industry for something that's completely new. The second one, maybe you get done in 2 years. After that, maybe you're able to put them out every 18 months. But by that point, have what would be a pretty hefty process in console development that's built on a potentially unstable foundation. The last note on Hollywood. The other interesting thing is residuals. When you release a game, for especially console titles, you have like 8 weeks to derive money from that. Otherwise, the sales figures basically drop off. There'll be a bunch of people that'll go buy 10 million copies on day one, and maybe a couple people that buy them after that. Otherwise, there's nothing. We don't have a lot of merchandising, at least with our company. There aren't DVD sales. The business model is very boom and bust, which is why you've seen the rise of freemium models, if you're familiar with that, or DLC. It's an opportunity to try and make a more steady revenue stream to reduce the risk associated with those big development costs. The last one, I don't know that I've ever really heard anybody outside of our online teams refer to our users as users. They're players. And that's a fundamental difference, because users might use something to solve a problem and then not think about it again. Our players are our friends, our family, the people we grew up with. They're the kid next door. They're the people at the supermarket. They're probably you guys. And I'm sure all of you have an opinion on something we've done right or something we've done wrong on the game. And I'll be surprised if a few of you don't take the opportunity, and I encourage it, come talk to me afterwards and express a few of those opinions. The point is, even our players have intense passion about what we do. And so it causes, again, decisions that you might be willing to sacrifice a small piece of your user base in order to make some big change. That's really hard for us to do. All right, so that you have a bit of a sense of the size of things, so that the rest of what I say has some context. Games are huge. I mean, ridiculously huge. The binaries that we're going to create for most of these things, just the executable binaries, are in the hundreds of megs. The game artifacts themselves, I mean, that's a DVD from the PlayStation 2 generation. That was still a 5 gig bundle at the end. The Blu-rays we're putting out these days are 25 to 50 gig. That's the game. Something like FIFA that has 20 SKUs, that means they're producing 50 gig artifacts, which we might be trying to get to QA on the other side of the world every night. It's a phenomenal amount of data, a phenomenal amount of storage that we need to have, and a phenomenal amount of traffic just to be able to move these things even into your local automated testing environment. As well, I should note, code base sizes are in the 20 million plus range. The teams themselves are actually quite large. A small team for us, say 5 people. A medium-sized team, probably a couple of dozen people. A large team could easily be 100 people. And the really big teams, the ones that do the games that sell extremely well, easily 500 people all over the world. And to really be extreme, probably all checking into the same branch. Think about that for a minute. 500 people all checking into the same branch, no integrations. Don't have any time for that. We have to get those builds to QA, the most current build to QA all the time. They need to be checking fun and authenticity. You're off working on your feature in a branch for a week. You have to spend a couple days integrating it. QA's been waiting on that. It's not an efficient way to do things. It is actually easier for us at this scale, if you can believe it, to just have everybody work in one code base and have an army of automation trying to fill in those gaps, to do all that testing, validate everything as quick as possible, so that if you break something, even though there's that many hundreds of other people working, you're disrupting as minimal as possible. And there are lots of games that do smarter things. Maybe they have a handful of branches, but the point is people are not working in private branches and then integrating into some type of main trunk. We may only do that for the most extreme changes. Source code repositories. I've already spoke a little bit on how we do that, but the most important thing to know here is that a sync size for us, 300 to 500 gig on average. We don't have things that you could nicely put in Git, and maybe they're meg or hundreds of meg, and you can move around nicely. They're huge. If we have to recreate a build environment because something's corrupted or we've had a security issue, even as much as we can optimize that, we're still talking hours just to be able to get the sync back. VMs. As you can imagine, the hardware that games play on tends to be pretty powerful. The hardware you need to make them on, equally so. The average spec of a dev machine is going to be something like 12 to 16 cores, 64 or more gig of RAM, and that's going to be the average stuff. The guys that are doing rendering or that are actually converting some of the assets from source into the final stuff might even have beefier machines than that. That means the VMs that we're going to be using to do this stuff are going to be beefy as well. Average spec is probably going to be 12 cores, 36 gig of RAM, and again, that's going to be a basic machine that isn't, it's not that it's not doing something intense, but it certainly isn't doing our most intense stuff. And we'll get into it a bit later, but we have thousands of these things. When Sasha was talking about their cloud offering yesterday, certainly they have more masters than we would ever consume, but from a pure host perspective, I think we could probably give those guys a good run for their money. For our Jenkins installations, our teams obviously has significant size ranges, so you see the same thing here. For a tools team, you might see 5 hosts attached to that. For a mobile team, maybe you see a couple of dozen. A medium team, that team that had a couple dozen people, will easily have 100 hosts. A big team will be in the hundreds of hosts, 3, 4, and those extra large teams can easily be in the thousands of hosts. I don't know that we have anyone who's actually broken that yet, but I'm sure if I go look, we'll find that they're pretty close, and they'll do it in the next cycle for sure. Something like FIFA or Battlefront or Battlefield, these are huge titles. From a performance point of view, so that you have a sense of what our build times are like, for most game developers, a no-op build is going to take a couple of minutes. If they actually change the code, 5 minutes, not necessarily best case scenario, but average experience. Could be worse than that if your game hasn't been maintaining their build system. Could be better than that if you have a really great build engineer. The important thing is that it's expensive. And that's for a single build of a single configuration for a single platform. We're generally developing for 3 platforms. We usually have about 4 configurations. If we're taking an average time of 5 minutes, that means for every change that you do, you're looking at an hour of build time just to be able to make sure that you didn't break everything, which again, if you're working with 500 other people, is a big deal. And that doesn't include any of the time that you put into testing that stuff. It's not practical. So it goes back to that army of machines that we were talking about earlier. Some quick milestones. This is almost the last of the context, and then we'll really get into some of the real dirty laundry. The company started in 1982. I have it on good authority that people really didn't start seeing what you would consider a nightly build until about 1999. I have no idea what they were doing in that 17-year gap. I don't even want to know how old I was. 2001 is when they started seeing what they acknowledge as the first continuous builds. I started with the company in 2006. At that point, they were definitely doing what you might want to consider CI. They have some builds. They're probably testing most of their, not testing, sorry, they're building most of that configuration matrix I mentioned earlier. Probably not too happy with it, but we'll get into that. The important milestone here is it's 4 years later, only 6 years ago, was the first time that I'm aware that we ever actually shipped the game. That is, the game that you may have bought in the store was actually produced by the CI system. Prior to that, for all those years, that game build was actually hand-built on someone by their desk, almost assuredly completely not reproducible, and probably done at the wee hours of the morning. 2010 was the point where the build's just lying around waiting for someone to say, yeah, that's the one we should ship. It's a huge milestone for us. All right, so who am I again? Why am I here talking? I'm the technical director for the development and release engineering team. This is probably the largest build engineering team at Electronic Arts. We do the build automation, test automation, a variety of that type of stuff, CM, CI, CD, for the majority of the development teams at Electronic Arts. The vast bulk of the console development teams and a good chunk of the mobile development teams. These are just some quick notes so that you guys have a little bit more of a sense of scale. It's about 70 people in 8 locations. Our model is to actually embed build engineers with the game teams. This way the game teams have someone who feels like part of their team, someone they control that person's time, but they don't have the ability to take those people and make them work on bugs or whatever their whim is. They're basically restricted to working in this space. They're part of our team, so they have a bunch of other people who do the same job as them, that have the same problems that they have. They form a community. And that's really the way to think of it. My team is more of a community, which certainly leads to some of the other problems we're going to talk about. Those partner teams or the game teams I'm talking about, for some reason that I still haven't figured out, they really like us. This customer satisfaction is extreme. Our team health scores are amazing. We'll get into why that is in a little bit, which causes us a problem. It means we have almost no attrition. I'll get into why that's an issue. 97% job reliability means 97 out of 100 jobs will deliver a useful result to the game developers. Whether that's a pass or a legitimate fail doesn't matter to us. It's 3 out of 10 deliver garbage back. That could be because our build system is crazy, which it is, or it could simply be network infrastructure issues, run out of storage, who knows. But the point is that 97 is pretty good for us. When I started, it was very low. And our Jenkins instances are up about 99% of the time. But like you, even at 99%, that's still giving all sorts of why don't we have high availability? Why is this ever down type questions? And so we have all the same problems that you guys have. The team considers itself a DevOps team. It's a mixture of build engineers, test engineers, automation engineers, sysadmins, DBAs, infrastructure engineers. You get the point. Developers, obviously. Last thing I want to call on this, at the moment we have five CI systems like Jenkins actively in place. We are almost completely converged on Jenkins, but in the last 10 years, we have had 10 different systems for this. Partially that's due to the team size. We find our way into new studios who have build engineers. They want to be part of the community. Maybe they've been using this different tool. But the point is we have huge perspective on why Jenkins is so good, and we'll get to that later. All right, so the real journey begins about 10 years ago. I started on NBA Live 08. And same problems you guys have either seen and hopefully are not still seeing, but the ones we all know how to solve. CI is not working particularly well. The developers don't have any trust in it. The results are hit and miss, and if they're not perfect, people really don't care about the value that it's adding. Beyond that build engineer type role is one of the hardest. They're doing everything manually. Those QA builds, as I mentioned earlier, are being built at their desk by them at all hours of the night, and they're waiting. They just sit there waiting. They're not doing a lot of work, but they're waiting for someone to say, this change list, add these ones to that, and get that build off. They're also then the first person in the morning because they're going to hit the button to run that build, which is probably going to take, back then, about 6 hours. And you had no idea if it was going to work or not. The pipeline was super unreliable. And so you need to wake up in the middle of the night. If it didn't work, hit the button again because that fixed it. Or you come back in the morning and you hit it then. But even if it is working overnight, you're coming back in the morning, you're quickly burning that to a disk to pop it into a kit to make sure that that works and is playable before we go burn a whole pile of those for QA. At that time, QA testing was largely done on Blu-ray discs when Blu-ray discs were brand new. So if you need to burn $20 discs for 100 people, as the build engineer, you need to make real sure that build actually works before you just spend that money on Blu-ray, and that's every day. That's not something they're doing once a week, once a month. That's an everyday cost that they have. Fortunately, we do everything digital now, so it's not such a big issue, but it was important. So how we got to the point where we felt we needed to solve these problems, why did all this happen? What was the scenario that caused this? It was games development, and in 2006, we didn't have mobile. The barriers to entry into game development was huge. I specifically recall looking on BioWare's website when I was looking for a job, and it basically said, don't bother applying if you don't have a master's degree. And that was pretty much the state of the industry. If you have experience, we'll hire you. If not, go get some. And so people would take any job they could. They would take a job in QA and work their way up into dev. They would take a job as a build engineer knowing all these problems in hopes that at the end of that year, that game team would hire them on as a game developer. And they could seek that glory I mentioned earlier, but they would work on this. And it wasn't working. That was why the CI state was as bad as it was a revolving door of build engineers. Every single year it was the most junior person on the team. And you could not necessarily burn that person out, but you could survive off their backs, but you really couldn't thrive. Someone had the idea to make a team called Orca. That's my cue to remember to talk about Orca. The desire for that team was to pull all these various build engineers out of the game teams that are constantly poaching them, put them into their own team, put them at arm's length. So as I said before, the game teams can't pull them in for bug fixing or other things. Let them be that community, let them start to grow. Same as you guys, however you solve these problems was likely how we solve those problems. That's not the exciting part. The exciting part comes after we solve those problems. When you don't know where you're going, people will just start going places. This was the biggest problem we ran into. So we solved those problems and we started asking ourselves, what comes next? We didn't have a plan. We didn't expect to solve the problems. We kind of had free time. It was a bit of a weird experience. So it wasn't obvious, so we started asking around to try and make up for the vision that we didn't have. So we went to our business leaders to ask them what they thought we should do next. And I mean, you guys will have experienced the same thing. Business leaders' goal is almost always world domination. So that wasn't particularly helpful. So we carry on, and we make the biggest mistake that I think we've made in the last decade, which was we asked our devs what we should do next. Now, at this point, as I called out, the only people on the team are devs. There wasn't some other group we could have asked. We're not DevOps yet. DevOps isn't a thing we've heard of. We're not even accepting that we really have an operations type role yet. So devs do what devs do best. They want to develop. So of course what they come up with is, well, we should go build something. That's totally the right thing to do. And in the absence of leadership, which we'll get into in a minute, that was what we did. So we started building our own continuous integration system. Because this team of junior engineers that had just slogged getting us from no CI to actually reasonably good CI felt they really knew what they were talking about. We could go build our own system. We were quite worthy of that. So, I mean, the lesson here, obviously, probably don't ask devs, but we'll touch more on that later. But really where we had gone wrong was we weren't asking whether we were dev or DevOps. We weren't focused on what our goal was. And the mistake wasn't that devs can't be trusted. It's that devs can be trusted to develop. And so if you aren't sure that's the right thing to do, you need to get different perspective. And unfortunately, at the time, we weren't able to get it. So why did we start building our own CI system? What was the cause of that? And how did that not get stomped out by any intelligent person in the company? Like I said, we had a junior team, so it seemed like a really good idea, developers. I actually, as a side note, really like to tell the story of this to potential hires of ours, just to gauge what their feedback is. One of the brilliant ones, which we did hire, told me that he felt it was totally inappropriate for anyone to develop their own custom CI system until their workflows had stabilized, basically hadn't changed in years. At that point, building your own system allows you to take advantage of your specific changes, but prior to that, general systems were absolutely the way to go. I support that. That makes a lot of sense to me. I suspect as Jenkins users, you guys are probably also on board with that, but if anyone wants to duke it out afterwards, I'm completely available over lunch. Anyway, back to this empowerment problem. And this is going to be a recurring theme for the team. Because we keep throwing people into the non-sexiest role at a video game company, the build engineer, well, maybe QA could win that, but we're pretty close. We keep getting these people that are wanting to go over to development teams. There's something different that they want to do. And so the way we offset that is we empower them. You can solve however you want to solve this set of problems. In fact, I remember my manager at that point going, I don't even care how many hours you work. If you work 0 hours a week, but you've managed to find a way to have the computers take care of all of this for you, I will happily pay your wage for that. That was a huge incentive. I'm a lazy person, as you can probably tell from my slide deck. And so that type of incentivization was pretty much the pinnacle of what I could possibly hope for. Being able to have the power to change that, to shape my fate, to solve the problems, to help my customers, I couldn't imagine anything better than that. The problem is, we really didn't have any countering force to that. So when it came down to standardize these things, there was no force that caused that. We kind of did it on whim. And this is, I guess, where we can talk about the lack of technical leadership. Part of the problem there was that was a bit of a revolving door job. Same as you can imagine, the build engineering role was a bit not particularly interesting. Being the top build engineer, or the people who told all the build engineers what to do, also not particularly interesting. Relatively hard to keep that role staffed. And beyond that, even if we had a really good person at the helm that was trying to keep us from doing that stuff, it's super easy to convince all the game teams that they're their own little private snowflake, and they really need to support you to go make this change. And as I said already, we got to the point where we'd largely taken them from terrible CI systems to things that were super functional, that were really working well for them. So at that point, there was a lot of trust and a lot of credibility. If we said we could deliver even better by building our own thing, they were going to support us in that argument. Fortunately, pressure caused us to change. This is about the same time. I'm going to guess it's about the Gen 3, PlayStation 3, Xbox 360 transition. The CI, as I said, has been working really well. Game teams start to grow phenomenally in terms of size, in terms of their CI install, the consoles they're using for testing. We're really on the bandwagon at this point. And so we go from, when I started, maybe we're talking about 8 jobs just running on builds, no tests, to hundreds of jobs running a battery of builds and tests after that. So the operational work required to keep all that alive, and if anyone's ever worked with a dev kit, you can think of it as any mobile device, any embedded device, they're not PCs. You can't just nicely go, oh, reboot, you're doing something weird. You probably have to manually walk over to it and push that button, which means that it's going to break as soon as you walk out the door for your long weekend. And so at this point, things have started to get really bad. They're getting really hairy. We don't have time for development anymore. And that's really the thing that fixes this. We end up with this pressure to be more operational. We lose our time for development. We need to get something done. The system that we've been building is working pretty well, but it seems to break its scale. We just need another solution. And so I said at the beginning that we basically fell onto Jenkins by chance. This is about the point where someone starts evaluating Jenkins and goes, hey, all these problems with these other solutions we're dealing with, this doesn't seem to have any of that. Okay, that's super. And I'd like to say that we made a conscious choice to evaluate Jenkins and to ensure that it was the right thing to do and that it always would be, but we didn't. We did it once again. We reacted to the situation we were in, the pressure that we were having, and we ended up on Jenkins. And we'll talk about it a bit more later, but that's where my fear of what's the future going to do, right? If in 3 years' time Jenkins is bloated and it's big, and I mean, I love the idea of high availability and offloading the storage to somewhere else, but if that means I've now got to set up SQL databases that need to be run on high availability clusters themselves, suddenly it goes from something I can just run an installer and be online in a couple of minutes to this thing that's quite hefty and needs a lot of forethought, which was part of the problems we were having with our previous solutions. So basically, our business pressure forced us onto Jenkins by luck rather than choice. And I'd like to say that next time we've learned our lesson, but I really can't tell you what the lesson was. And this is where we get into the next problem we had. So we've all seen this before. It's represented by the triangle. We all laugh a little bit. And after I see all your smiles, then the reality sets in, and we all cry a little on the inside. Because this is the bane of all developers and development teams. You really need all three of these things, and you just can't have them. And so we thought, in our infinite smugness, that we knew exactly how to do this. It's relatively easy for a company that makes a game called Need for Speed to bias everything to be faster. And plus, it's build engineering, or it's CI, right? You want these things to be fast, right? So of course you're going to bias for fast. And we didn't really care what the other one was. The problem wasn't what we were doing, it's what we weren't doing. And it was complexity. Every single time we would pollute our system, we would add more complexity to it. And we didn't mind because we were growing up. We were going to be badass engineers like everybody else. We're developers. We were going to know all the foundational components. We were going to know all the tech stacks. We were going to know all the technologies. We were going to know every language. And then we would have credibility. And so we didn't realize what we were sacrificing at the time. And then this happened. You guys remember the market crash of 2009? That had hit probably on most of your companies. We thought ours might be immune. We kind of thought video games would be one of those vice things like smoking or gambling and drinking that still do pretty good during crisis times, but we were quite wrong. And so things went south. There are layoffs, as many companies had. And suddenly, all this complexity that we added to the system that had been completely manageable by just having these people that had been with us becomes our biggest liability. We have such a huge scope of technologies in place that it's impractical to hire anybody into it. Plus, it's now hard to even get full-time staff, or not full-time, permanent staff. You're often bringing in temporary people or outsourcers. And so anyone who's on a contract, even if you could get these people that have the capability to learn all the stuff you've built, they don't have the timeline in order to be able to actually do it. They'll be halfway or more than halfway through their contract before they even get to the point where they can start contributing. So complexity becomes our biggest issue. Now, hopefully you guys are thinking, you're a moron. The answer to this is reduce your scope, fool. Well, of course it is. Everybody knows that. And that's, of course, what we started to do. But it goes back to that previous problem, which is, how do we not do this again? I mean, it feels like every time we're presented with, how do you want to optimize this? Oh, it's got to be fast, and it's got to be whatever the other one is. Don't worry that it's more difficult. We repeat that pattern over and over again. We always underestimate that complexity because it doesn't hurt us at the time. It's that long-term thinking. Even worse than how do we ensure that this doesn't happen again? I'm not confident that we'd even recognize if we got into the cycle, the vicious cycle of this again. It took us years to recognize it the first time. I may have misinformed you if I said, hey, this happened in 2009 and we figured it out like that. We didn't. It was probably 2 years ago before we started going, oh man, complexity, how did we not notice that was the problem? And the reason for that, and I'm sure most of you guys are probably thinking it, debt repayment isn't fun. killing off technologies, dealing with the mistakes that you've made, there's not a lot of glory in that. It's like paying your bills. You know, you have to do it, but you're going to probably go out of your way not to, especially if there's no consequence to it. And for a long time, to the individuals, that was the problem. All right, I don't have enough time to get into all of the ways that we've been dealing with that problem, but the one I want to focus on is what we've been doing with Jenkins. So as I said before, we've by luck ended up on Jenkins, and I'd like to not screw it up again this time. So what we've done is put together a team. It's where the Jet is. It's the Jet team, Jenkins Enterprise team, and we've actually created a committee. And I know that you're not going to believe that this is going to solve a problem, but we're really hopeful. Basically, what we've done is empower this group of people to make decisions about what plugins we should be using, what versions we should be using, what configurations of versions should we be using, what are the specs of the machines. They make all the decisions around those masters so that everybody can stay on the same one, so we can stay converged, so that we don't have some build engineer or automation engineer or whatever who thinks they know better than everybody else going rogue, basically. And so how we did that, why we believe this will be effective, is we took all those people we knew would probably go rogue and we put them on this team. And then we put one of them in charge. And that person doesn't have the ability to go and beat anybody for being different. Basically, he's not here, I think. He's basically a tattletale. So what he's going to do is go back to me and the other technical directors and just be able to show, hey, here's the drift report. Here's how we're doing on these things. And we go back to those teams and assess, okay, why are you different? And the reason we do this is because it's easy to go, well, the solution was to standardize. The problem with that is if you standardize too much, you're going to block out your innovation, and then you're going to get disrupted at some point. You know, it was the same problem we had. I got to tell you, before we were using Jenkins, the big one we were using, BuildForge. Hopefully none of you are BuildForge users. I hope IBM isn't here. I'm sorry. We used that for way too long. And again, by luck, someone on the team had found Jenkins, and we kind of got our heads together and said, geez, we should have been using this years ago. We should have been using anything else years ago. And that was the problem. In the attempt to try and standardize on that, we had shut down and not kept our eyes on the prize. All right, so at the beginning I did promise that I would tell you how to do nightly builds. But what I've been trying to build with all of this is if you're trying to figure out how to build nightly in a development team where you have, say, those 500 people located all around the world and you don't have a period that's obviously identifiable as night, if you're trying to figure out how are you going to make that window, you're already doing it wrong. You're probably falling victim to these things that we were talking about. Now, there may be the edge case where there's a completely legitimate reason, but you may want to go back and rethink, why did I need these nightly things in the first place? What was the goal of these things? How do I streamline that? How do I fix that? How do I prevent this from happening so that I can do this as part of a continuous process or whatever solution works for you? Now, in case you feel that answer was a cop-out, here's what we actually do, because we still didn't do that. So each major location gets its own master. What did I put? Yeah, its own CI setup, basically catered just to it. Small studios usually don't get their own. That's just a cost measure. If you can spin up your CI instances easily, there's no reason not to have just a whole bunch of them. The reason to do that is the more segmentation you have, the more likely you are to have actual nightly periods. If you were trying to build everything on one master, and in one case we certainly are, you will definitely be butting up against this time window problem. Non-critical jobs can pretty much be located on any instance. There's no need for duplication. Non-critical being jobs like anything that's creating an artifact that I would say nobody cares about, but is maybe more an accountability thing, right? Maybe it's code coverage that you need to have eventually, but it's not an artifact that's part of the pipeline that someone is waiting to consume. The critical jobs below that should definitely be duplicated in every location. These are things like your QA builds, your unit tests, whatever it is that's needed to get a result back to people that they're actually looking for. What are the other things we're bad at? This is just a quick summary so we can get wrapped. Has anybody figured out how to report effectively? Because we haven't. We've been writing dashboards for 10 years, and I'd like to say we had a solution, but we don't. And I really hope the Blue Ocean will do better than what we've done, but my devs already don't want to look in Jenkins. They want custom stuff that is tailored to their workflow. So it feels like we're perpetually building different dashboards to try and keep up with changing demands. If anyone has oh, here's the visualization we figured out and everybody's been happy, please, please come talk to me. How to stop developers from developing. So one of the things I didn't get into when that point was relevant was even if I could re-roll my entire team right now, and I wouldn't, I love those guys, but if for some reason they all quit en masse and I had all the headcount, I could hire up a whole bunch of new people, I can't with confidence say that I know how to do it. I still haven't figured out how to really identify someone who has the development chops to actually support that still terrible tech stack that we have, and then choose to not actually develop when they can. Ops people are really hard to find, at least that have the scope that we have. And that ops mindset, I'm not sure I know how to identify it. Fix it versus replace it. This has been another real bane of our existence. When we virtualized, containerized, encapsulated, it's super easy to just throw things away now. I think there's an analogy about putting down cattle or something like that. Turns out we're really bad at that. And not because we really love doing root cause analysis. It's like pulling teeth to get my guys to do it. The problem is it turns out all our customers, even myself, something breaks and I want to know why. I can't help but ask why. And more often than not, why is terribly inefficient. And hopefully you guys are thinking about in your operations, how often is it actually valuable for you to go get that answer? More often than not, for us, it isn't. A lot of our issues are extremely transient. Maybe you'll see it once a year. If you're going to put 8 hours into finding something that has a 5-minute impact once a year, it's great to satisfy that need to know, but it wasn't effective use of time. All right, so what do we cover today? Always want to leave with those key takeaways. Games are crazy. That one was easy. With great empowerment comes great responsibility. I ripped that off from Spider-Man. Changed one word, but remember that. And then the path to crunch is paved with the right decisions. All along the way, I mean, I make it sound like we're a bunch of crazy people who had no idea what we were doing, but all of those decision points, I can go back and say with confidence, yeah, that was the right decision. That was the right decision. It's looking back through history's lens that I can make us sound like a bunch of crazy people, but at the time, it was perfectly reasonable. And so if you're sitting there going, man, I don't know why I came to this presentation. That guy didn't help me at all. Try to remember that the thing you think is perfectly right now, with just a small change like a market crash, could easily become your biggest liability. All right, that's it. Thank you. Questions? That's a really great question. Vadir flies from Stockholm to here, and then we meet here, and that's about it. No, I mean, it depends. So more often than not, we have a lead person in a particular zone that has a bit more responsibility to try and talk to those gaps. But certainly for our engine development team, half of those guys are in Stockholm, half of those guys are in Vancouver. That time zone has no workday overlap. And so, I mean, sometimes it's the really terrible solution of, in fact, I'd missed a meeting at 7:30 this morning because they wanted to have it on Stockholm time, and I simply wasn't going to log in. I was still sleeping. But more often than not, it's, okay, it's those forced meetings, or it's, you guys stay late this time, and we'll come in early that time. But more often than not, it's trying to get into actually really good handoffs, right? I mean, the analogy that we've used is like a hospital. They have shifts that keep changing. It's trying to look into those type of methodologies that they use, be able to adopt that stuff, and ensure that nothing slips through the cracks. So that's a really great question. Oh, he's asking dashboards. What have we actually learned about them? What are the mistakes we think we've made? What would we do? Easiest lesson, and no offense to any of the CloudBees guys, I think Blue Ocean is awesome. I feel like the problem that it's going to have is it doesn't represent the full set of views that people will actually want to see. The developer who checked in the code wants a very different view than the lead that person is accountable for. The product owner probably wants a global sense of what's happening. I just want to see that my guys are actually following up on the stuff that's broken for us. My guys don't care whether it passed or failed. They just want to see if it's something that they need to go take action on. And that ends up being the root problem, is that ultimately all that data is useless if it isn't actionable, and just about every party's definition of actionable to them changes. And so trying to find any framework to solve that problem, that's where we keep going wrong. And I would say if we just broke down, identified all the different parties, and wrote dashboards for each of them, we might be a lot closer to a solution. But for some reason, we keep trying to make one-size-fits-all solutions. We're trying to do all the dashboards on one framework, and that's simply failing. Anybody else? All right, let's eat. Thanks.